Hi guys, welcome to Mr. Morrow's Algebra class. Today we're going to be talking about Lesson 1-1, Variables and Expressions. In order for you guys to really get a good handle of algebra, you need to know a lot of vocabulary, okay? And I know that sometimes it seems like, wait, we're not in an English class, why am I learning vocabulary? Well, in order for you to really understand mathematics, you have to understand the roots, okay, what everything means. So we're going to talk about a lot of vocabulary today. We're going to have a lot of information. I'm going to go very quickly. Remember, this is going to be a live video, so you can pause and write your notes as accordingly. So a quantity. Let's talk about what a quantity is. Quantity is a mathematical quantity is anything that can be measured or counted. If you can measure it or count it, it's a quantity. When you get a big bag of rice, there's a quantity of rice in there because you could count all the individual grains. There is a quantity of chairs in this classroom because you can count them all. There is a quantity of students in this school, okay, because you can count them all. Your height is a quantity because you can measure your height. So anything that can be measured or counted is a quantity. Some quantities are constant, okay, and some vary. Constant means that it stays the same forever. And vary means that it can change. And those are called variables, okay? And a variable, gentlemen, is a symbol, usually a letter, but it can be a symbol as well. But it's a symbol, it's usually a letter that represents the value of a quantity, okay? The value is the actual amount of that quantity. For example, you get a quantity of donuts. Okay, that means that you got some number of donuts. But if I get a dozen donuts, now I have a value. Well, if I say I bought X donuts, that's a variable. Until I tell you the value of that X, it's just an unknown variable at this point in time. So a variable is any symbol or letter that represents a value or a number. Now, numerical expression is a number sentence or a mathematical phrase, okay, involving numbers and operation signs. No equal signs. If you add an equal sign to an expression, you're going to get what's called an equation. So a numerical expression will be something like 3 plus 5 or 6 minus 4 plus 11. It's just a number sentence using numbers and operation symbols, operation signs. An algebraic expression is a numerical expression which contains one or more variables, okay? So an algebraic expression will be something in the sorts of 3x plus 5 or negative 2y minus 8z plus 4. Okay, that's an algebraic expression. It's got numbers, it's got variables, it's got operation signs. Make sense? Awesomeness. Okay, now, in order to write these expressions and eventually equations, we're going to be practicing writing equations as well. Okay, it takes time, first of all. I don't want you to get frustrated. It takes time. But it's going to take a lot more time if you don't memorize these key words that indicate mathematical operations. If you memorize these words, I'm not going to tell you that it's now super simple. I'm not going to lie to you. But it's going to be a lot easier. Sorry about that. That annoying sound was our bell. So algebraic expressions are written if you know what the operations mean. So, for addition, all of these words indicate addition. Sum, plus, more than, total, increased by, more than, increased, add, added to. Anytime you see those words being written in an expression, you're talking about an addition. The sum of a number and 12, that's x plus 12. 5 increased by a number y, 5 plus y. All right? Multiplication, product, times, of is huge. Multiplied by and per. Per can be used for both multiplication and division, depending on the sentence. For example, if I tell you, Best Buy is selling CDs at $5 per CD. And you buy 10 CDs. How much do you pay? How did you get that? What does that per indicate? Times, multiplication, very good. What I told you, the class trip of 25 students cost $1,000. How much was it per student? What would that indicate? What would that per indicate? Division, very good. So it depends on the sentence for that. Now, subtraction. Difference, minus, less than, decreased by, reduced by. Two very important ones here. Less and less than. Please pay attention to this. This is going to save you a lot of heartache later on. If I tell you x less 7, straight up, it's x minus 7. Easy. Now, what if I tell you x less than 7? What do I have to do there? That's exactly right, sir. It's going to be 7 minus x. So why? Well, whenever you have this less than, gentlemen, that indicates, hey, dude, flip the end for the beginning. Bring that last value to the front and that first value to the back. So less than indicates switch. You feel me? Awesome. Now, division. Quotient divided by, divided into, per, out of. Those all indicate division. Equals, is, was, were, will be, any tense of to be. It's always going to be equals. John is 12 years older than Mary. J equals 12 plus M. Okay? Inequalities. Now, for the inequalities, guys, what happens here is a lot of times people get confused with this greater than and this less than. They think it's adding or subtracting. But you know that it's going to be an inequality because of the word is. Is, as we just found out, means equals, okay? So when I say something is greater than, so when I say is greater than, we're talking about greater than or equal to, depending on how they write it. If I say is less than, okay, less than, then it's less than, because it's is. Now, I have is at most and is at least. This is a lot of times written in word problems. And at most is less than or equal to. And let me try to explain it to you so you can understand. Mr. Morrow is at most 40 years old. What does that mean to you, that statement? I'm 40 or younger, right? Okay. Now, at least, my students are at least 14 years old. What does that mean? But not that they could be older. That they're 14 or older. Okay? So please be careful with the at most and the at least, gentlemen. Does that make sense so far? Okay. Let's do a little practice. 2 times a number increased by 5. 2 times a number increased by 5. 2 times a number increased by 5. 2 times a number, 2x, increased by 5. Definitely not 10. Okay, now, how about the product of a number and the sum of 12 and 9?
X.
The product of a number and?
Plus.
No, it's the product of a number and the sum of 12 and 9. I've got to read these. 5 times a number less than 15. Yes, sir.
5.
No. 5 times a number less than. So what is that be? 15 minus 5x. 7 less 3 times the number. Half acre. No, 7 less 3 times the number. Yes, sir. Awesome, dude. Awesome. How about 7 less than 3 times the number? 7 less than 3 times a number. 3x minus 7. Awesome. How about 9 less a number? Yes, sir. 9 minus x or n or w, whatever you want, but I like to use x a lot. The sum of twice a number and 12. The sum of twice a number and 12. So it's the sum of twice a number, 2x, and 12. Well done, son. The product of 1/2 of a number and 1/3 of the same number. The product, think about this one, guys. The product, so you know you're multiplying something. The product of 1/2 of a number and 1/3 of the same number. Does that make sense? Or you could write it more professionally, 1/2 x parentheses, 1/3 x. Okay? That'd be more professional, but that works. But do you see that? The product of 1/2 of a number and 1/3 of the same number. Yes?
All numbers for 2, like, so like 12 plus 9, x times 12 plus 9, can you just write 12 x times 21?
Yes, but that's once you start solving it. Okay? All right. May I continue? Okay, thank you. Okay, equations. We're not going to learn how to solve equations today, I promise you, so don't stress it. All we're going to do is learn about what an equation is, what a closed and open statement is, and also we're going to learn how to write some equations. Okay? So an equation is an algebraic expression with an equal sign. So now we're talking about numbers, operation symbols, variables, and equal signs. Okay? And using word phrase translations, it is easy to write equations. One key to writing equations successfully is to label all given information and variables. Just remember to label things. People do really poorly in word problems and writing equations because they don't want to take the time to write down the information. They just want answers. They want it now. And that's unfortunately not the way math works sometimes. So we got to really pay attention and label things, okay? Now, there's 2 types of equations, guys. There's a closed statement and an open statement. A closed statement is a statement basically that is either going to be true or false. For example, 7 plus 2 equals 9. That is a true closed statement. It's closed because it's done. It's true because it's true. But it's a closed statement because there's no figuring it out. You're not looking for anything here. 7 plus 2 is 9 or it's not 9. That is true. Over here, though, 7 plus 2 is 10. That is a false. Not a false true statement. Hello. That is a false closed statement. I apologize about that typo. Okay? Now, an open sentence. An open sentence, you're going to be dealing with a variable because it's open. The whole point of open is we don't know what the variable is. You got to solve it. It's open to interpretation. So an open statement is basically a question which is asking for the value of one or more variables. For example, x plus 3 equals 9. That's an open statement because we don't know what x is. We know it's 6, but you understand what I'm saying, right? Whenever you're looking for a variable, you're looking for an open statement because it's open to interpretation. Does that make sense?
Yes.
Thank you, guys. Okay. Let's practice writing some equations now with equal signs. Write an equation for the total cost of a given number of DVDs if each DVD is on sale for $12. Okay. This is the way I like to work things. I like to label. total cost here, I'm going to call C. Me, personally, that's what I want to call it. You want to call it something else? I don't care. Just label it, please. Okay, then DVD number 3. And then I'm going to label DVDs. That's going to be my X. You feel me? Now with those two labels, can anyone help me out and give me an equation for this? Yes, sir. Thank you. The total cost C equals $12 per DVD X. Done. Very simple if you label, in my opinion. Very difficult if you don't label, in my opinion. Find the total cost of a meal if each drink costs $3.50 and each entree costs $12. Now, in this particular case, again, label, 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 label. I'm going to call total cost C. Now, you have drinks and you have entrees. Can you label those with the same variable? No, thank you. Thank you, thank you, thank you. So I'm going to call drinks, what do you think I'm going to call drinks? D. What do you think I'm going to call entrees? E. It's not because I'm so smart. It's just because I like to be simple, actually. Okay, does that make sense so far? So, who can tell me what the total cost here will be, gentlemen? What are you doing? No, go, Baba. No, you just gave me an expression. Yes. No. Oh God, no. Okay, guys, I'm not trying to be rude, but think about it. Pretend you're out at a dinner right now. You're with your girlfriend, okay? Isn't your total cost gonna be $12 for every entree plus $3.50 for every D drink? Come on, guys. Okay, but you didn't tell me what the labels were. That's the thing. I cannot read your brains, guys. If I could read your mind, wow, that'd be really cool. But I can't. So you're going to have to really let me know what's going on. I'm not making you read my mind. I labeled my variables. And then I simply plugged it in. Okay, wait a second. The cost is $12 per entree plus $3.50 per drink. Done. Does that make sense, gentlemen? Do you understand your mistake, my man? Thank you. Thank you. Thank you. Okay, now, sometimes I give you tables. Whoa. And with these tables, you got to give me an equation from these tables. Well, over here, cost, we're going to call the cost C. And we're going to call the change from a 20, let's call it, okay, X. Doesn't matter what you call it. You could call it CH, I don't care. Label, though, okay? So what's happening here, guys? Let's look at the pattern here, and then let's try to decide if we can figure out an equation for this. It says that when the cost is $20, the change is 0. When the cost is $19, the change is $1. When the cost is $17.50, the change is $2.50. When the cost is $11.59, the change is $8.41. So how can I represent this table in an equation so I can find the change from any amount from a 20? Yes, sir? Perfect. X change equals 20 minus C the cost. Awesome. Does that make sense, everybody? You promise? Yes? Okay. So does that make sense, everybody? Okay. Awesome. Let's do 2 more real quick. All right. What about this? Use this table of values to write an equation. I've earned $15 and then I saved 750. When I earn 20, I save 10. When I earn 25, I save 1250. When I earn 30, I save 15. Let's call earned E and S saved. How can I relate this equation to figure out exactly how much I'm saving? What did I do to this 15 to get to 750? What did I do to this 20 to get to 10? What did I do to this 25 to get to 1250? What did I do to this 30 to get to this 15? I divided by 2. Give me an equation then. Savings equals earnings divided by 2. Bam. Now if you plug in any of my earnings here, does that equation work? Does that make sense, guys? Are you seeing the rhythm here? You promised me. Okay? Let's do one last one. Bless you back there. Okay. Use this table of values to write an equation. If I work 7 hours, I get paid $49. If I work 9 hours, I get paid $63. If I work 15 hours, I get paid $75. That's wrong. No, it's not. Yes, it is. Yes, it is. Yes, it is. Pay attention, Mr. Morrow. Should be 105. Sometimes I don't use my brain. I apologize. So let's go ahead and call hours worked W or H. Well, I'm going to call it W. And let's call total pay P. So how do I figure out how much I'm making? What is my pay going to be? How do I figure out my equation for my pay?
Pay equals
P, which is total pay, equals W 7 times W. Yes. How does that work, Morrow? Well, when I worked 7 W hours, is that 49? When I work 9 hours, is 9 times 7, 63? When I work 15 hours, it's 15 times 7, 105. Now, what's the point of this, Morrow? Who cares? Well, now, if you want to find out how much you're going to make and you had a big week and you worked 40 hours, how much is your pay going to be? 7 times 40 is going to be $280. Does that make sense, guys? Okay, please remember, watch the 1.1 and 1.2 videos. Also print out the 1.1 and 1.2 PDFs. Watch the videos at home. Fill them out. Thank you very much. Great class.